Hello and welcome to this video. I could not record math videos for English for last 4 5 days. I am terribly sorry for that. So here we continue the permutation and combination problem number 201 to 210. And I'll say, which I always say in my videos, that when I'm stating the problem, you should pause the video and try to solve the problem. If you cannot solve the problem, we can look at the solution or skip the problem and go ahead, solve other problems, come back later. The other thing is that you should not spend more than 15 minutes on any particular problem. If you cannot solve in 15 minutes, leave it. Come back later. The link to download the PDF will be in description, as well as at the end I will show you how you can download the books. So without further ado, let's get started. So question 201 says that there are n letters and n corresponding envelopes. In how many ways can the letters be placed in envelopes? This should be D. One letter in each envelope so that no letter is put in the right envelope. So this is a straight case of derangements, and you can directly use the derangement formula. Or you can do the same derivation which is done for derangement, right? So we said that that n letters be denoted by 1, 2, 3 to n. Let AI denote the set of distribution of letters in envelope so that only ith letter is put in the corresponding envelope. Now, number of AI would be n minus 1 factorial, because rest or remaining n minus 1 letters can be put in n minus 1 envelopes in n minus 1 factorial ways. Similarly, if you want to put two letters in correct envelopes, that would be denoted by n AI intersection aj, and that would be n minus 2 factorial, and so on. Now, you need to think carefully, and you will see that what we have to do is n a1 complement. Okay, that is one letter is being put into correct envelope. Sorry, only one letter is being put into wrong envelope. That is the first letter. Okay, is being put in the wrong envelope. That is what is the meaning of A1 complement. And A2 complement is putting the second and letter in the correct envelope. So the intersection of all these will give you the required number. Now, from set theory, we know that such a set is represented as A1 union A2 union A3 through AN, and then we take complement of that. Now, this is basically n factorial, that is total number of ways, or you can treat it as universal set minus number of A1 union A2 union up to AN. Now, this number, this set is given by sigma NAI, sigma NAI intersection AJ, and so on. Now, if you look at sigma NAI, so NAI we have already figured out to be n minus 1 factorial. Now, if you put I is equal to 1, 2, 3 through n, that is basically you are selecting one out of this. So that is NC1. Okay, this NAI means you are selecting one out of n. So it is NC1 multiplied by n minus 1 factorial. Now we have to find sigma NAI intersection AJ. So we have already known NAI intersection AJ is n minus 2 factorial. And AI AJ means picking 2 out of n. So NC2. And so on. And when you expand all this, you will arrive at the derangement formula. 1 minus 1 by 1 factorial is removed. Sorry about that. So this is 1 minus 1 by 1 factorial is removed because both will end up becoming 0. Now we move on to question 202. Find the number of non-congruent rectangles that can be formed on a chessboard. So number of non-congruent squares is 8, because 8 squares can be formed in 1 by 1, 2 by 2, 3 by 3, and through 8 by 8. So this will form 8 squares, which are non-congruent rectangles. Now, this is counterintuitive, this 8C2. So what you can do is to form non-congruent rectangles is you take one one square from length side. Once you pick one square from the length side, from the breadth side, you can pick 2, 3, 4, 5, 6, 7. So we have 7 total rectangles. Now we pick 2 from the length side. Now if we pick 2 from the length side, we can't pick 1 from length side or 2 from length side. Because if we pick 1, we will get a congruent rectangle with 1 by 2. 1 multiplied by 2 and 2 multiplied by 1 will be congruent. And we cannot take 2 as well, because 2 multiplied by 2 is a square. Or rather 2 by 2 is a square, not multiplied by. So if you take 2 from the length, then from the breadth side, you can pick 6. That is 3, 4, 5, 6, 7, 8. And similarly, if you pick 3 from the length side, then from the breadth side, you can pick 4, 5, 6, 7, 8. So basically, you have 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. These many non-congruent rectangle. And using the arithmetic progression formula, the sum would be 7 multiplied by 8 by 2, that is 28. The 28 plus 8 is 36. Question 203 says that show that the number of ways in which 3 numbers in arithmetic progression can be selected from 1 to 3 up to n in 1 by 4 n minus 1 whole square, or 1 over 4 n into n minus 2, according as n is odd or even. So we let the 3 numbers to be a, b, c, which are in AP. So we can write that a plus c is equal to 2b. Now this equation implies that a and c are both odd or both even, because the sum is even. So we take the first case when our n is even. If n is even, we can write n is equal to 2m. So number of odd and even integers numbers in this case would be same. Both will be m, because these are continuous numbers, right? So number of ways in which a and c can be selected is 2 multiplied by mc2, which is equal to m into m minus 1, which is equal to 1 by 4 n into n minus 2. Now the second case is when n is odd. In that case, n is equal to 2m plus 1. In this case, number of odd numbers will be m plus 1, because we start from 1, so odd numbers will be more. And number of even numbers would be m. So A and C can be selected in m plus 1 C2 plus mc2 ways, which is equal to 1 by 4 and minus 1 whole square. We just need to expand it and put the value of m. M would be n minus 1 by 2. So just substitute it and you will get the answer. Question 204 says that 2 packs of 52 playing cards are shuffled together. Find the number of ways in which a man can be dealt 26 cards so that he does not get 2 cards from the same suit and same denomination. So we have 2 packs of 52 cards. Therefore, number of cards from the same suit and denomination would be 2 for each card. Now we select 26 cards out of 52. Notice that we are not selecting 26 cards from 104, because we want the cards to be unique. There should not be duplicate cards. So it is 52C26. But each card out of 26 can be selected in 2 ways, because there are 2 packs. So we have required number is equal to 52C6 multiplied by 2 to the power 26. Question 205 says that there is a polygon of n sides n greater than 5. Triangles are formed by joining the vertices of the polygon. How many triangles are there? Also prove that number of these triangles which have no side in common with any of the sides of the polygon is 1 by 6 multiplied by n multiplied by n minus 4 multiplied by n minus 5. So for n sides of polygon, we will have n vertices. Now selection of any three vertices will give us a triangle. The number of selections is NC3, that is n multiplied by n minus 1 multiplied by n minus 2 over 6. Now number of triangles formed having two consecutive sides common with the sides of polygon will be number of selection of three consecutive vertices of the polygon, that is n. So take two sides and go on moving up around the polygon and you will have that as n. Now number of triangles formed having exactly one side in common with sides of polygon is equal to number of selection of three vertices out of which only two are consecutive. So suppose you have a polygon, you take one side. Once you take one side, you can't take two adjacent extra vertices. So four vertices you can't pick anymore because two already you have chosen and two are not available to you. So remaining would be n minus 4. So total number would be n multiplied by n minus 4 C1 because the side can be any one of the n sides. So that is equal to n multiplied by n minus 4. So required number would be NC3 minus n multiplied by n minus 4, which is equal to the required number, that is n over 6 multiplied by n minus 4 multiplied by n minus 5. Question 206 says that n different objects are arranged in a row. In how many ways can three objects be selected so that all three objects are consecutive and all three objects are not consecutive? So we let three n objects O1, O2, O3, On. So the possible solutions will be we pick O1, O2, O3 or O2, O3, O4 or O3, O4, O5 or On minus 2, On minus 1, On. So you see the count will be n minus 2. It starts from 1 and goes up to n minus 2. Now number of ways to select three objects out of n objects without restriction is NC3. But following from 1, we have the required number as NC3 minus n plus 2. So out of total, you subtract the consecutive ones, so you get non-consecutive ones. Question 207 says that there are 12 intermediate stations between two places A and B. In how many ways can a train be made to stop at 4 of those 12 intermediate stations so that no two of which are consecutive? So let A be the number of stations before stop 1, B be the number of stations before stop 2, C be the number of stations before stop 3, and D be the number of stations before stop 4, and E be the number of stations after stop 8. So A plus B plus C plus D plus E will be 8 because that is the total number of stations where the train won't stop. Now here A may be greater than or equal to 0. B, C, D will be greater than or equal to 1 and E will be greater than or equal to 0. So we can say that X is equal to A, Y is equal to B minus 1, Z is equal to C minus 1, T is equal to D minus 1, W is equal to E. So we get X plus Y plus Z plus Z plus T plus W is equal to 5. Now the required number would be number of non-negative integral solution of the above equation, that is n plus r minus 1 CR, that is 9C5 or 126. Now we move on to question 208. There are m points in a plane which are joined by straight lines in all possible ways. And of these, no two are coincident and no three of them are concurrent except at the points. So that the number of points of intersection other than the given points of the lines so formed is m factorial by 8 multiplied by m minus 4 factorial. So number of this m should be capital. Number of straight lines formed by given m points will be MC2, that is m. Total number of points of intersection of these two lines would be MC2 under given conditions. Now we consider a point A1, number of lines passing through A1 would be m minus 1. Number of pair of lines intersecting at A1 would be m minus 1 C2. Similarly, this will be the case for other points. Therefore, required number of point of intersections is MC2 minus m multiplied by m minus 1 C2. That is m factorial by 8 multiplied by m minus 4 factorial. This should be, I believe, MC2. No, yeah, this should be MC2. Question 209, I'll fix the typing mistake. It is a typing mistake. Question 209 says that find the number of ways of choosing M coupon out of an unlimited number of coupons bearing the letter A, B, and C so that they cannot be used to spell the word DAC. The word DAC cannot be spelled if M selected coupons do not contain at least one of A, B, or C. Number of ways of selecting M coupons which are A or B is 2 to the power M. This also includes when all M coupons are all A or all B. Similarly, for B and C and for A and C, the number of ways of selecting N coupons where all are A is equal to 1. Similarly, for B and C. Therefore, the required number would be 2 to the power M plus 2 to the power M plus 2 to the power M minus 1 minus 1 minus 1. That is 3 multiplied by 2 to the power M minus 1. Question 210 says that a straight is a 5-card hand containing consecutive values. How many different straights are there? If the cards are not all from the same suit, then how many straights are there? So the straight cards could be 1 through 5, 2 through 6, 3 through 7, and so on, up to 10 through KA. Thus, we see that there are 10 such straight hands. One card of any denomination can be picked from any of the suits in 4 ways. Thus, 5 cards of 5 different denominations can be selected from 4 suits in 4 to the power 5 ways. Thus, number of ways of making selections is 10 multiplied by 4 to the power 5, that is 10,240. If all cards are not from same suit, then number of ways of making selections is 10 multiplied by 4 to the power 5 minus 10 into 4. That is 10,200 because there are 4 suits. This is an extra. So with this, we come to the end of 24th set of problems on permutation and combinations. Let me show you how you can download the book. So you go to my website astrolock.org and click on the second link to download Algebra, and on the third link for trigonometry. Coordinate geometry should be ready by tomorrow, and I'll upload it here. So make sure when you download, you add the date to the file name because the file name does not contain the date. As soon as I update to the PDF, I change the date here. So with this, I will end this video. I hope you are enjoying this series of videos and finding the videos useful and informative. If you are watching this video in isolation, make sure you watch the entire theory of polynomials, permutation and combinations. And optionally, you can watch the entire playlist where we have covered logarithm, progression, complex numbers, and polynomials, and theory of equations. So I thank you for watching the video. Keep practicing. Don't wait for the video to be available. And if you have any questions or comments or questions from any other books also, you can ask me in the comment box and I'll be happy to answer that. So I'll take my leave then. You keep practicing and working hard, and we will meet again tomorrow. Till then, enjoy.